Okay, welcome back, guys. We have a T-shaped bracket that is supporting 4 loads, as we can see in the figure, and we need to determine the reactions at A and B if one condition A is 10 inches and in the second condition we have 7 inches for A. So as always, we're going to start with the free body diagram. So we have the beam in here, and so we have two different supports at point A and B. A is roller, which means the only force that we have is a normal force. Let's call it A. And since it's a roller and we are neglecting the effect of friction, so there is no X component, and we're gonna call our X and Y this way. And in point B, we have a pin support, which means we have both X and Y component. Let's call this one BX and this one BY. And the rest of the forces are, we have 50 pounds in here, 30 pounds here, and we have the 10 pounds. So that's pretty much all the forces that we have, and we can start with our equilibrium equations. And let's start with the Fx. So we're gonna do sum of all forces in X equals 0. Since again we are in equilibrium, the only force that we have in X direction is Bx, which means our X component at point B is 0. If we go with the sum of all forces in Y direction, we obviously have two unknowns, which means it's better to start with the moment equation, then we can cancel out one of the unknowns. We can go with the moment about point B. That way we can cancel out the moment of the 50 pounds force, since it's in the line that connects where the 50-pound force is applying and the point B, so we don't have any moment for the 50-pound force. So we're going to do the sum of all moments about point B, counterclockwise positive, and that's what we can do. So we're going to use the 2D shortcut that we have for the moment. I'm gonna put the link in the description. There's a video that you can learn how we can use the 2D shortcut in finding the moment in 2D questions, and it's simple enough. We only need the force in X and Y direction and the vertical distance to the point that we are finding the moment about, which in this case is point B, to the line of action of the force. But in this question, everything is in Y, all the forces are in Y direction. So we have the force already in Y direction, and all we need to do is all the distances, or I should say vertical distance, to the line of action of the force, which, well, we have that information too in the question. So it's pretty easy enough, and we just have to be mindful about the direction of the moment. Let's go with the 40 pounds force. So as we can see, the 40 pounds force in here can make a counterclockwise moment, so we have a positive moment 40, and the distance will be this distance, which we know is 6 inches. Let's move on to the 30 pounds force. So this time we know all the forces on the right side are going to make a clockwise moment, so there's a negative sign for each of them. So 30 times the distance would be what we have for A, which varies in the two conditions that we have. Well, let's just find it in general form, and we can use it when we have the numbers for A. And the next one would be the 10 pounds force, and the distance this time will be here to here is 8, and this is A, so we'll have 8 plus A. And the last one would be the moment of A, which is also a counterclockwise moment, so it is positive, and distance would be 6 plus what we have in here, which is also 6. So will be 6 plus 6, or 12, equals 0. And now we can find the capital A based on the small a. So if we do that, we have 4 times, so here we have 4 times 40 times 60, which is 240, and we have 240 minus what we have in here, which is 10 times 8, so 80. And what we have for A, we have minus 30A plus minus 10A, which is minus 40A. And if we bring everything to the other side, we will have a negative sign in here. So at the end, our A will be 40A minus 240 minus 80, which is 160. So negative sign, it will be positive here, divided by 12. So from the first equation, we found A based on 40A. So that was for A. We can do the same thing for BY. We can either go with the sum of all forces in Y direction, or we can do the moment about point A. That way we get rid of A as a variable and we'll find BY based on the distance A, or the small a that we have in here. It's up to you, we can use both, but let's just for sake of practice, let's go with the moment. So we'll go sum of all moments about point A, again counterclockwise positive. And since everything is on the right side other than the BY's, it's going to make a clockwise moment, so everything will be negative. So we have minus 40 times 6, have minus 50 times 6 plus 6, or 12. We have minus 30 times 12 plus A. And the last one is the 10 pounds force times 6 plus 6 plus 8 plus A. So it's 20 plus A. And we have the moment to BY, which will be counterclockwise, so will be positive, and the distance is 6 plus 6, or 12. And if we do the same thing, we get BY based on the variable that we have for the distance. And if we calculate the top part, we get 1400 plus 40A. Now we are all good to put the A in these equations, and we can find the two reactions that we have at point A and B. So we're going to start with the A part of the question, where the A is 10 inches. So if we do that, we get our A 40 times 10 plus 160 divided by 12. And this condition is gonna give us 20 pounds for A, and our BY will be 1400 plus 40 times 10 divided by 12, and this will be 150 pounds. And if we want to go with the second condition, where we have A 7 inches, our A this time will be 40 times 7 plus 160. So I think there is a mistake in here. So this is a plus sign, which means we have a negative sign in here, and also negative sign in here, and also a negative sign in here, 2 divided by 12. So this will be 10 pounds, and our BY will be 1400 plus 40 times 7 divided by 12, and this would give us 140 pounds. So all the direction shows that what we assumed for A and B at the beginning was correct, and all the directions are the way we have in here. So for A, we had it at the beginning downward for A and upward for BY, and this shows that these directions were correct in both conditions, A and B. And that would be the final answer for this question. Thanks for watching, and you guys take care. I'll see you in the next video.